Hello and welcome everyone. Thank you for joining us today for our webinar on the role of industrial connectivity in industrial data operations. My name is Shelby Heggie. I'm the head of Kepler Marketing, and today I'll be your moderator. Just one note before we get started, feel free to drop any of your questions into the Q&A panel at any point during today's presentation. We've set aside time at the end to address these questions. Now, let's dive in and meet our speakers. Today, we're fortunate to have Abby Eon, the General Manager and SVP for the Kepler business, as well as Sam Elsner, the Head of Solutions Consulting for the PTC Kepler business, on the line with us today. And without further ado, I'll turn it over to Abby to kick us off.
Thanks, Shelby, and thank you everyone for joining us today. So before we jump in, I did just want to baseline on what we are seeing in the market today in terms of manufacturing trends. And all of this is this big demand and excitement for data, which is awesome for all of us in the industry. So one, really thinking around, AI, I'd say primarily is the hot topic, as you all know, but thinking about smart manufacturing and AI in places where we can draw new insights and, drive towards operational resiliency as well. And then also thinking around to those ends, how do we go after that and modernize architectures? Because if we look at what's existing today, we have a lot of siloed systems out there that don't communicate broadly, or they have data, but it's not in context and very difficult to use. We also have the emergence in these modernization of systems of a lot of edge-first, edge-driven architectures. Ultimately, to be able to deploy AI and advanced analytics and be able to do that at scale with trustworthy results, folks need to modernize their architectures. So everyone is talking about AI, but what we know is that in order for AI to be successful and to give you the insights you're looking for, you need a solid data foundation. And that's why we're seeing manufacturers embracing this concept of industrial data ops. So data ops, if you're in the IT side of the house, has been around for quite some time. What's unique about this is OT brings in more complications, particularly around, siloed data sources that have a complexity because they don't easily self-describe or have the context that allows you to take that data into something like AI and make it actionable. So at the highest level, we would say, industrial data ops is around orchestrating, contextualizing, governing, and delivering OT and IT data. But really, if you go down more practically, there's some really core principles. And the primary places that most people are talking about are processing and contextualizing that data, as well as unifying and distributing it. But all of that comes down to this foundational capability of connecting, normalizing, and securing. But because we are talking about industrial data ops here, I do want to touch on the contextualization layer and what that looks like in the real world. So I am going to turn this over to Sam to talk a little bit more about that.
Thanks, Abby. I'd love to. So I'm Sam Elsner. I manage and direct our solutions consulting team. Glad to be talking with you today. So just as Abby said, the ability for businesses to respond to the changing demands for data comes in a bunch of different forms. Let's first look at historically the ways that context data was turned into information. So let's contextualize at the consumers. This means plug your data in, get it to the end application, and then hydrate it with context there. Build what it is, build relationships with it and other data, but not an intentionality about it distributing or sharing those data structures or schemas or models at anything but maybe other components of that same end system. So that's where we're coming from. Now we look at IDO. So data ops, as Abby said, comes in a lot of different forms. So we'll look at contextualize and distribution first. The implementation of contextualize and distribution looks an awful like hub and spoke architectures a lot. And the reason for this is that message brokers can occupy the space of hubs. They can have additional layers added on top of them to provide schema, governance, maybe protocol conversion at that layer to different interfaces. But at the very least, there is a central or collection of central hubs that fan the contextualized data out in the environments like spokes. The context itself, the information set, is added in a couple of different layers in the distribution channel. It is first foundationally important to normalize and secure that data. That's where we play. From there, the data is handed to typically data pipelines. The data pipelines are putting a schema against the raw, unstructured, but normalized data that we're providing. And then that message takes different steps along the way in the pipeline before it's stored in the hub and then distributed out from there. The second area where context is added in the distribution channel is the hub itself. And the area where that data is placed implies a hierarchical relationship or a lateral relationship with others. So it's two parts. It's the data models themselves change, and then the relationship of that data model is implied, oftentimes today at least, by hubs with simple hierarchical context. The next step that we get into is contextualizing repository. So these are very commonly called industrial data management solutions. You could think of them as data platforms and data archives and data lakes. You could think of this as similar to Snowflake, typically cloud deployed, but not always. Data management seeks to centralize the application of context and enhance the already potentially contextualized information. Maybe you have a schema that represents one type of machine, but the context in repository will add metadata layers to that to add in and weave in information from very disparate systems. Maybe it's a maintenance system. Maybe it's an HVAC system that's time series correlated with some of the model states or model instances or data sets we're getting from that lower OT model. So all of that metadata is stored specifically and very carefully in this concept of a catalog. And on queries, the IDM solution allows you to hydrate information, to synthesize information from the model store with information from the metadata catalog, giving you much faster mean time to value, especially for AI and analytics applications. Now, one more future-looking application for IDO. This is particularly exciting. It's model-based management across the enterprise. Imagine a world where you have meta models, different submodels for every single component in your environment, from a software interface for your business app to a PLC controller with an ENet module, right? If that can describe itself and everything can understand each other intuitively and natively. A lot of IDO applications in future states look like schema management across the enterprise, everything from lightweight constrained devices up to big enterprise systems running in clusters of virtual machines or on Kubernetes. It's the same language, the same semantic understanding across the enterprise. And IDO seeks to manage that and make it an effective way of building industrial data fabrics, digital twins, and driving manufacturing operations. Looking back at the genericized view of the modern industrial environment, we can see that connectivity should be a foundational element of any OT-IT integration approach. Any modern architecture should focus on an industrialized, enterprise-grade, managed connectivity layer for connections, normalization, and security of data. We eliminate point-to-point integrations between devices and systems. We eliminate the need for bespoke custom integrations outside of a standardized approach. We eliminate the use of insecure protocols and ultimately create a single source for OT data across the enterprise. We accelerate data access for smart manufacturing use cases to the degree that projects that include standardized connectivity grow and by orders of magnitude faster and higher scale than if bespoke connectivity was required late in the deployment and scale process. Connectivity isn't just an afterthought. It's part of industrial data ops, and it's absolutely the critical foundation. So let's dig into this a little bit more. So here's what it looks like without a connectivity strategy as you approach these modern architectures, right? We're getting away from stovepipes where things just connect to machines, or maybe things just connect to Kepware alone, an ERP system, an MES just by itself coming down and connecting to Kepware. Well, obviously, for the course of the conversation today, we're doing this and approaching it quite a bit differently now. But the problems still exist. The left is a unified namespace concept without a standardized connectivity layer. It's a spaghetti diagram again. The stovepipes end at the distribution and unification layer, but my goodness, there's a lot of stovepipes down below that. Multiple touches with PLCs to read potentially redundant data. Custom integrations might be required, or you could approach it with connectivity available in other systems. And then you have proliferation of connectivity tools from multiple vendors across the organization. Again, just as folks are trying to standardize as a way to drive digital transformation and modernization. So at the right, is an IDM, an industrial data management approach, cloud-centric in this case, without a standardized connectivity layer again. And look, again, stovepipe architectures, connecting devices directly to the clouds, and it's expensive to maintain for a host of reasons. So Kepware helps you standardize your connectivity at scale. We connect, we normalize, and we secure. By ensuring interoperability to virtually any northbound application using standards like MQTT, OPC UA, HTTP, and database access. And of course, southbound, we connect to virtually any device, physical systems, software APIs, everything found in OT and a healthy degree found in IT. And so why should each device type be connected to a standardization layer? Well, let's look at what the architecture looks like if we add in the standardization layer in our more modern approaches. Recall on the left side of the diagram here, connectivity provided to a unified namespace without any type of standardization, a mixture of protocols, stovepipe connections, independent, maybe even duplicated systems. Now, you also have independent connections from the manufacturing operations systems that might need deterministic access and control with those target devices. So you've got a slurry of connections going every which way, yet again perpetuating this mess of connectivity. Meanwhile, you're trying to digitally transform and standardize as many parts of your environment as possible. So if you instead look at the environment on the right, you can accomplish the same goals much faster, more securely, and with faster time to value. So standardized connectivity provides that single source of OT data for both types of use cases, manufacturing operations that might be touched by industrial data ops, but other types of analytics and data capture and data acquisition routines that are heavily standardizing on different context models today, simultaneously in parallel. The other benefit of standardized connectivity is that the connectivity layer can support simple OT to OT use cases. We can transfer information within the Kepware layer itself, back and forth, without necessarily propagating it well farther up your organization. So if there are important and private and insecure pieces of data that should not leave the manufacturing floor, well, we can move those between instances of Kepware, between machinery, and keep everything in that local control network. So now, if I really want to get into how unified namespaces are built with Kepware today, I get excited because then I think about the different kinds of contextualization engines we have in Kepware. And we primarily have built manufacturing operations solutions and provided an unstructured data set that's normalized and reliable and secure for everything else. There are some pieces of technology, though, that I want to make sure people are aware of. So our MQTT publisher has a plain text modeling engine built in. And you can build some fairly sophisticated payloads. And you can swap those payloads, that formats of those payloads, around using your development operations systems via our API. So you can provide a simple schema within Kepware and propagate that entirely across your initial standardized connectivity layer so that the base schema for whatever else you're doing up top is at least part of that foundational connectivity. From there, we can group objects together. We can provide math and data operations on the messages in flight prior to moving the system data out of Kepware and into the MQTT broker, scaling, derivations, a few different types of expressions, math and logic operations can be added to. So between the math and logic operations and the light contextualization engine in our MQTT module, it is enough to get started building your own unified namespace right away. Now let's look at another use case. So transitioning into industrial data management more specifically, we spoke earlier about how IDM architectures look without a standardized connectivity layer. So let's look at that again. Many stovepipe connections, and then the question to ask of what happens if we can't connect or talk to this or that. If we look at the diagram on the right, Kepware today has validated integrations to Azure and validated integrations to AWS, both for their cloud-hosted ingest points and for their on-premises edge utilities. So for Azure, we're able to publish secure MQTT to outbound cloud topics. We can also push those to a local IoT edge runtime, and we can push those to an OPC UA broker or an MQ broker in the new Azure IoT operations ARC. Deployments. For AWS, we support native integration, direct integration to IoT Core. We also support direct integration to IoT Greengrass via both the site-wise OPC UA connector and the built-in MQTT message broker. These integrations are helping Kepware customers today to approach IT and OT challenges like predictive maintenance. So now I'll pass it back over to Abby to talk about a use case where one of our customers achieved their goal of predictive maintenance with Kepware and an IDEO solution.
Thanks, Sam. So I'm going to walk you actually through two separate customer stories. But to Sam's point, the first one is going to be around predictive maintenance. But if we back all the way up, this is a global packaging and delivery distributor. And you can imagine that downtime is very expensive for them. But during the pandemic, downtime was like critical, just could not happen. So they had a lot of legacy equipment in there, and they really wanted to be able to be more predictive and to reduce downtime and make sure that their operations were going in that environment. So what they ended up doing, it was bringing in Kepware for a standardized data layer, because in addition to all of the legacy equipment they have, they actually brought in a lot of new devices. So they had, different kind of IoT sensors and new equipment and cameras. So they needed something that would bring those all together in a holistic fashion and then expose that for upper level systems. So they brought that in. They had a collection of their normalized data. And at that point, they're able to bring in an IDEO solution because they wanted to do more with the processing contextualization. And that actually ultimately built into a cloud system. And what's really unique about this vendor is they have their contextualization system, and then they were using a cloud vendor. And because they built everything open and interoperable when it came to standards, they were actually able to swap out cloud providers, which is, a pretty big piece of that solution. And that's just like a great example of best practices. So there's an example for predictive maintenance. The next customer I want to talk about is a large automotive. So they have been a Kepware customer for a very long time. When you think of process automation, automotive, so they're using a lot of Kepware. They have a lot of cells. They have a lot of facilities. So kind of informally, they had standardized on Kepware, but now they got to a point where they're trying to modernize and bring forward the architecture. So this became much more intentional, and they were building out like their next generation architecture diagram, and we got to sit down and have some good strategic conversations. So this one's interesting as well, because in addition to having, the automation landscape they already connected through Kepware, which is a huge accelerator, they were able to bring in more modern devices as well. But in this sense, when we think about contextualization, they had something unique. So they were building towards like their own proprietary protocol that was standardized, so that all of their facilities across were talking in the same way, and they could send, similar semantic models across. Because they are in automotive, now all of a sudden we have, from a US-based manufacturer, US Car is coming out with standards. So as much as US Car is helpful for standardizing on what they're trying to communicate and how they model their data and make sense out of it, they still have their own like proprietary way that's very deep into their systems. And that also has maybe information in it they wouldn't necessarily want to be putting in their US Car model, where they're sharing that with different distributors. So it's actually a really great story of like standardizing connectivity, but then on top of that, being flexible so that you don't just need to think about contextualization in that system in one way. That might be multiple different ways that you're architecting that. And because of the fact that you're designing it in those layers, you're able to do that in a way that is future-proof and that you can update as your needs change. So we've been talking a lot about Kepware, and Kepware, for those of you who don't know, is really the global standard for industrial connectivity. So we've been trusted across all verticals, different company sizes, and we've really been innovating for 30 years now. So we've had a lot of people who've had their roots there and been able to build up their process automation. And now we're coming forward into this next generation of modern architectures where people are doing some really incredible things with this data. Now that we've talked about who Kepware is, I want to talk a little bit about why Kepware is uniquely suited to standardized connectivity that we've been talking about. So Kepware, when you think about interoperability, and I just described those customer use cases and how important that is to build that way, we really do have the most interoperable connectivity solutions on the market. They're performant. They can connect to virtually any type of device or controller. And our most recent innovations have really been focusing on how we can do this all at scale. So we're thinking about standardizing across the enterprise. We're thinking about, all of these new needs for IT systems and cloud and the connectivity. Sam talked a lot about our capabilities there. While also making sure that we are, time-tested, hardened, proven connectivity when it comes to traditional manufacturing operations like HMI, SCADA, MES. So looking at those innovations, targeting that enterprise standardized connectivity story, we've been putting a lot of time, effort, and energy and making things simpler. So simpler to scale, simpler to make things secure, simple to connect at scale. And so some of this looks a lot like a single management plane that allows configuration and visibility to all of your devices. We've made advancements in how to make things very simple for your procurement team and make that administration very simple. We've also put in capabilities like being able to integrate with single sign-on and Active Directory support. So it really is this offering that fits into your enterprise landscape along with these other applications. So all of that said, what we are very excited about coming up right now is a new offering later this year, which is Kepler Edge. And this is a containerized Linux offering. And I'm actually going to turn it over to Sam because he is even more excited than I am, I think, in this moment. And he is bursting to talk about it.
Excited indeed. We are bringing out to market a Linux-based industrial communications platform deployed in a container. Robust reliability that you'd expect from our connectivity platform with the first set of drivers, Allen Bradley, Siemens, and Modbus. Now, unmatched interoperability right now is going to be delivered on premises and in the cloud for applications in UA or MQTT form. And then this has a 64-bit foundation with security first in mind. So not only high performance for any workload you need, but security minded so that we can continue to ensure that device communications are the easiest part and the most secure part of any kind of modernization effort you might need to do beyond that. So needless to say, Abby, I am very excited about this. And I understand that we have Q&A up next, and I hope I have some questions from our audience about it. So over to you.
Thank you, Sam, and thank you, Abby, for this presentation today. I hope folks have a good understanding of what is industrial data ops, how does industrial connectivity support industrial data ops, and how does Kepler help you standardize the flow of information from devices into those different modern architectures. I have a couple of questions here to pose to the both of you. Promoting this webinar, we shared this with IT audiences and OT audiences. And Sam, I know you've done a lot of research on industrial data operations and what is it. I think for this audience, it might be good to level set on the understanding since we have diverse groups. So the question is, how does data ops compare to industrial data ops? And what are the differences?
Sure. Yeah. So data ops is an enormous category where it focuses on orchestration, contextualization, governance, and access to information in context. So not the raw signals, not just the normalized and secure stuff that Kepler provides, but additional layers of context above and beyond that for ease of use, for full understanding, and a wide variety of systems participating in this. So the difference with industrial data ops is that it's taken the principles of data ops and moved them into the industrial factory, deep into the plant itself, where we're using these concepts of data pipelines and message brokers to provide that type of context that might, for data ops efforts, be normally orchestrated from a cloud platform only. So that's one of the differences. Another difference is that the type of information dealt with in industry is a lot smaller. The data point updates tend to be high in volume and very small. So millions of data points of unstructured data is looking and feeling a bit different than some of the data ops ingest routines that data ops in more IT-focused spaces have set out. Now, that is not always exclusively true. You go ask the engineers at Facebook or Twitter how small their tweets are, how many thumbnails their message ingest pipelines have to deal with per second. I think it's probably going to rival whatever we're doing in industry, but it's not that far away. Hundreds of thousands of unstructured messages per second have to be dealt with. So we have a particular set of tools and practices that are emerging to make it really well applied to industry, but it's a bit of a derivation and a bit of a borrowing right now.
The other question that I wanted to pose to you, Sam and Abby, is that we know that there are probably a lot of folks on the line who already have Kepware today in their factories. Can you talk a little bit about how taking a standardized approach to connectivity is different than what they might be doing today, and how they might progress from, using Kepware in pockets to standardizing their connectivity at scale?
So what we're really dealing with now are a lot of different buying patterns. People can find Kepware from their favorite resellers. They can find Kepware from PTC directly. They can find Kepware on websites. They can buy it online without ever talking with us. And what we'd say is that we're ready to start talking with you about your focus on industrial connectivity as being an enterprise application that you bring in to your management portfolio, just like you're managing your other applications. We have APIs for continuous improvement in DevOps with the containerized Linux effort coming out this fall. We have a deployable instance that can live on Kubernetes and begin to be part of your development operations pipelines, in addition to your data operations pipelines. So we would say now is the time. Focus on standardized data layer to connect to your physical systems, to normalize those signals, to secure access for them so that whatever you choose to do for your transformation efforts up top, have that as a foundation so that you'll have an easier, faster time to value.
I would just add to that. What we see in a lot of customers taking this jump is really a shift from, kind of this project-based mentality of like, what's the next thing that's up, to more of a strategic plan when they think about connectivity. Which ties in really nice because most companies are doing something with digital transformation and they have new projects. And a lot of companies we're seeing right now are thinking about, global automation and how do we improve those operations. So it ties in nicely because there are strategic roles there. And, by standardizing on Kepware and thinking that more strategically in terms of where it's deployed, how that's managed, where it's updated, that's a really helpful thing for customers as they evolve.
Abby, this is a question for you that has come in. Can you speak a little bit about the future vision for Kepware and help them understand where we're headed in the market?
So we've talked a lot around, industrial data operations, industrial data management. I think the thing that's really notable about this is, when I first started at Kepware 10 years ago, it was described to me that this is a very slow moving industry, right? Like manufacturing, it doesn't change that much. And now this is just in stark contrast. So these needs, Sam has described, we've talked about, taking data and putting it into new systems for new use cases and the need to process that and contextualize and how we make that available. Those are fairly recent needs, relatively speaking. And all of a sudden, this whole market has popped up, right, with a bunch of different solutions. So from where we're sitting today, we're really focused on that connectivity layer and understanding that our customers are choosing all of these different approaches that Sam highlighted with you, and also understanding, that market is going to be going in different directions for a while, and customers themselves may be changing from, solution to solution. So our goal is to make sure we have that best-in-class connectivity and that it is just very simple and easy to securely connect and to scale whatever solution you're going in. So if you have a best of breed solution where you might be picking several different components, if you're working with a solution stack, maybe it's from an independent company or maybe it's from an automation vendor, wherever you're doing that voyage of thinking about how you take these contextualization principles and how you're building out your new digital transformation initiatives, that's the place where we are really doubling down and making sure that is enabled and making sure we fit into that ecosystem, making sure we participate in unified namespaces and all of the other things we've talked about today.
A question has come in. You spoke about unified namespaces and how Kepware and standardized connectivity feed data into unified namespaces. Can you speak a little bit about whether Kepware today supports SparkBug-Lee?
Yeah, that is such a good question. So we do work with customers today that are looking at SparkBug-Lee. I think we mostly see it in POCs, a handful of stuff that we've seen at scale right now, but I understand that's the market is new and emerging. So what we would see that, and like we've been talking about, Kepware as a connectivity enabler to those upstream systems. They're consuming those capabilities within usually like an IDO solution or maybe in an MQTT broker. We're definitely thinking, as we watch the market and see what this implementation looks like at scale, that is definitely a future consideration of bringing that closer and having that in the product.
Yeah, and if I could add too, Sparkplug B is a fantastic SCADA protocol, and it has just enough really important features to use it for creation of a schema if you don't have it already. And it lays out how to create a message broker infrastructure to provide that messaging interface out to the entire ecosystem. So it's very, the pathway is paved for you to start a unified namespace initiative with some of the ability for Sparkplug to solve some pretty important problems for you. But when it gets to a certain point, especially when it starts to scale, you quickly realize that Sparkplug was not intended as a contextualization and distribution language, a schema where flexible, let's model the outside world and share it with others. And it is a fantastic tool with an express purpose. Its express purpose is objectively not to create unified namespaces. And we can do it, and we are doing it. It just may be a point in time until we can get either interface standards that do pass schemas and support schemas that we can blend into DevOps or data ops, and until more systems perhaps support open standards that do this already.
Great. Another question has come in, and I'll leave it up to you, Abby and Sam, on who to best answer this one. But the question is, what is the relationship between manufacturing operations applications like MES and SCADA and their role in industrial data operations and modern architectures?
I am going to give that one to Sam. I know he has a lot of passion and excitement on this topic.
Yeah, I'll try not to spend 5 minutes because I think we have about 15 seconds. So very related, but not the same. So industrial data ops is used by manufacturing operations. So it is what is potentially managing the distribution of schemas and understanding of information across the systems that MES is participating in. So it might be that MES is governed by an IDO solution to always put incoming data in this type of model, in this type of context. In the future, I think we'll see IDO a lot more focused on end devices, physical systems actually representing themselves with models and how to transit that level of understanding up and down the enterprise. So very much an enabling technology for manufacturing operations, but mutual exclusivity exists to a significant degree.
Thank you, Sam, and thank you, Abby, for your time and energy put into this presentation today. I hope our audience has left with a better understanding of how Kepware supports industrial data operations. I just want to take a moment to thank all of our attendees for their time and attention today, and also let you know if you're looking to gain more information about what Kepware has been up to and recent advancements in our Windows product, or get a preview at our Kepware Edge product for Linux. We are hosting a webinar on July 16th to talk through and show some of these new innovations. We'll also have Sam Elster there to answer more of your questions about what's new and how you can deploy connectivity at scale. So please go to ptc.com/Kepware to register for that webinar. And of course, if you want to stay in the know about other happenings with Kepware, about building a business case for standardized connectivity or finding customer references, I encourage you to visit ptc.com/Kepware as well. Again, thank you everyone for joining. I hope you have a great rest of your day.